last presenter is from Charmi Bhatt. She's a PhD student in astronomy, supervised by Jan Kami. Charmi's research focuses on molecules in space. You had me at molecules. For those who don't know why that's funny, I'm a chemist. Okay, so she uses data from the James Webb Telescope to study cool, evolved stars. And that just made me think of a question. So when we say cool, is that like James Dean cool, or is that like temperature cool?
I would say the second one.
Okay, good. Okay. I just had to make sure. Charmi completed her undergrad in physics in India before moving to Canada to pursue her master's degree at Western. Charmi loves talking to people about science and how the universe works. She works as an outreach assistant at the Cronin Observatory, co-organizing outreach events. She occasionally writes science blogs for her website and produces science videos. She's a collector of space merchandise, designs websites, and composes animations. So please welcome Charmi.
Hi. Since we are already talking about biology, let me ask you this. Have you ever wondered how life started on Earth? Think about this. We are made of carbon. DNA we have has complex carbonaceous molecules. We also know that all the carbon we have in our bodies was made inside stars. So what happened in between? How do carbon from inside of stars ends up on planets? What happens in between? We don't know. To solve that mystery, we first need to figure out how complex carbonaceous molecules form in space. And that's exactly what my research is about. I study molecules in regions like this. This is a picture of dying star. At the center, there's a star which upon its death expel most of its material out. Yes, that's what stars do when they die. They expel most of the material out, forming these beautiful rings around it. Those rings right there, that's where we have found complex carbonaceous molecules. And we keep finding new ones. And every time we find a new molecule, it just blows my mind. Because it shows how wild and different physics and chemistry in space can be than what we know on Earth. A question I get a lot is, how do we study these molecules which are floating millions of kilometers away from us? That's my favorite question. Let me tell you how. We start by receiving light that these objects give off using telescopes. And see, these objects are very far away, very faint. So bigger the telescope, better we can see. The one that I use for my research is called JWST, right here. The mirror of it is as wide as a tennis court. So yes, really big. Once we receive that light, we split that into its colors. All light is a mix of many colors. So when we split it into its colors, we see a spectrum, as you can see on the computer screen here. You know, we say an image is worth 1,000 words. Astronomers say a spectrum is worth 1,000 images. Yes, it has a lot of information in there. We see a bunch of signals from atoms and molecules out there. So by studying the light, we can not only identify what is out there, we can also understand what the region looks like. What's the temperature out there? What's the density? And if you do that for different objects, you can figure out the whole story of how we go from carbon to complex carbonaceous molecules. And let me tell you this, as astronomers, we cannot do this all alone. And I like how interdisciplinary this research is. We often work with chemists. They tell us what chemical reactions can occur in space, what cannot. We also work with computer scientists. They can develop models for us to simulate how the signals from molecules would look like. So yes, with this team effort, we are soon going to figure out how we form building blocks of life in space. Thank you.